Hello everyone, welcome to the HSPF training by DSI. In this video, I'll show how to generate water balance report using HSPEXP+. I'm trying very hard to keep my videos below 10 minutes. Sometimes they go longer. I would suggest you to run the videos faster so that you can see only important information that you need to. I apologize for them being longer than 10 minutes. So let's quickly look at the water balance report. So we did this HSPEXP Plus run last time. So once you have done a decent calibration, you understand all of these things that are going on. We want to see if how much is the water generated from each land use, and how much is the water coming in each reach and going out of each reach. So this water balance is constituent balance report. Click on water. Before that, you have to make sure that binary files are being produced at monthly interval, and we have gone through that topic before. And when I click on water, this or any of the constituent balance report, this box becomes active, and I say that I want the water balance for the watershed. I also wanted area weighted information at this location, at this reach. So this is the outlet reach, and sometimes I want output for receiving water model. So let's ignore that for now. At 54 we'll do that. So click on start. I think there is a bug, and sometimes it will say that HBN file does not have any data, so you have to make sure that uncheck everything else and just run the water balance report. Now if the HBN files have too much data, too long of a data, and like at a higher frequency, then this may take a long time to run. Click on OK. So then in the same folder, it has generated bunch of new files, so you'll have to probably look at. So this is the monthly loadings. If you see, this is monthly loadings is not so important for water balance. It's important for others. So let's look at the data. Okay, so it water land loading. So for every land operation, it talks about how much the water came in, how much the water got out. And my suggestion is to go through each one of them, and these can be opened in Excel directly, and to understand how they work. What I would talk about is a couple of important files. So this is the whisker plot, box and whisker plot for loadings. And when we look at sediment and other constituents, we'll have the similar graphs. For each land use, it says how much runoff is being generated. So urban being generated more runoff is good, is what is obvious. And then barren, in among the pervious land uses, barren has the highest runoff, total runoff. Total runoff means surface runoff, interflow, and active groundwater runoff. And forest is low. Wetland and forest are similar here, which is understandable, and so you have to compare all of these land uses and sometimes adjust parameters accordingly. So these are land uses, and what we can do is we can look at this averages. So the same thing that we saw earlier, we can in the box whisker plot, the same thing is here in more detailed format. So it might be difficult to see it in a text format. So what we'll do is we'll open Excel. And okay, so here it says that for water wetland land use, so this is for the entire watershed, it's saying almost 36 inches of rainfall fell on. So since there are different land uses distributed differently, and there are different meteorological stations, so the rainfall is different. Okay, so out of 36 inches of rainfall that fell on water wetland, only 0.06 was the surface runoff. And then rest of it is, then some of it is interflow, base flow and total is 5.4, and then the potential evapotranspiration applied to that land use was 33.5, 24.5 evaporated. So depending upon the land use, and similarly you have for impervious land. So water wetland, you can compare it to urban, and you can see that there's not too much difference in the evaporation that is happening. So you might want to adjust the parameters accordingly. But as you can see that in terms of surface runoff, urban has more surface runoff than wetland, which is expected, and barren has far more. So you will have to adjust parameters accordingly, just to make sure that this characterization of naming or land use as forest makes sense physically also. And that's what it and that's where I will stop on that description, and then you can see the same information in different ways. So I'll stop there. This is the description of just looking at water balance. So this concludes how to create a HSPF model, how to start doing HSPF model hydrologic calibration, how to look at the output, and how to interpret data, and what to interpret it out of it is dependent upon your specific project that you're working on. So if you have any questions on that, please feel free to contact me. From here onwards, we'll move on to sediment calibration, and again I'll just talk about the mechanistic aspect of like how to start doing sediment calibration, and what are some important things you can look at while you're doing the calibration. And from there then onwards we'll move to some other constituents as well. So thank you so much for your time. This concludes the HSPF 400 course. I'll see you in HSPF 500 course. Thank you.